Good afternoon, everyone. My topic for today's presentation is design of steel chimneys. Like as we all know, these chimneys are utilized every now and then for most of the industrial structures. So, as a structural engineer, we need to look at the design concepts and the design aspects of the steel chimneys. But before going further, these steel chimneys will be explained in the four modules of as the part one. I'll tell you about the introduction and what is the introduction regarding the steel chimneys. What are the types of chimneys in the second module, and the third module we talk about the design aspects, design methodology, and the relevant standards utilized for the designing of steel chimneys. In the fourth module we'll see about the design of the we'll take up a design problem, and then we'll discuss about the design aspects and designing of that particular steel chimney. So talking about the introduction in the first module, first let me tell you about the functioning of this steel chimney. uh, why do you think that steel chimneys are used for? It lets out the few gases with harmful chemicals into atmosphere at a higher elevation ratio, and which is useful for maintaining the environmental and ecological balance. Now talking about the application of the steel chimneys, firstly we all know that it is used for power plants. Secondly, we see the steel chimneys in the processing plants as well, like in cement processing units, refineries of oils, chemicals, fertilizers, etc. So it's very essential, based on the structural scenario, that we look at our steel chimneys and like what are the types of chimneys which we see all around us. So there are various classification. The first type is based on the material of the windshield. Windshield is a particular structural element of the steel chimney. So based on that, the outer covering, if it is made up of steel, then it will be called as steel chimney. If it is made up of RCC, that is reinforced concrete, consider reinforced cement concrete, then it will be called as a RCC chimney. So our focus will be on the steel chimneys. Secondary is on the based of the lining material which is used for the chimney. If the lining material is used as a brick, then it is called as a brick liner chimney. And if similarly, if it is used as a steel liner, then it will be called as a steel liner chimney. The third classification is based on the number of flues in the particular chimney. If the chimney has a single flue as a for the flue gases, then it will be called as the single flue chimney. And if it has a multi flues, as in big industries, big chemical like oil refineries, as of Indian Oil, then it will be called as a multi flue chimney. The third and the most important classification as of our syllabus is concerned is on the basis of construction of shafts. So there are two types of construction methodologies with which we can construct a stack. The first one is the self-supporting stack. Then the second one is the guide stacks. In the self-supporting stacks, if you look at the figure over there, here you can see that there is a self-supporting staff. So what does it mean? That the lateral forces, like in the case of winds or the seismic forces, are transmitted to the foundation by the cantilever action. If you imagine a chimney and you just look at, it is just a vertical cantilever beam, as its foundation is fixed with rigidity and the upper one is free. So based on this cantilever action of the chimney, it transfers the lateral load as well as the seismic forces or the wind forces, like lateral forces in terms of wind or seismic forces, to the foundation. And then this chimney is also, and so only this chimney is called as self-supporting chimney, as it supports its own self with the help of this cantilever action. Second type of chimney is the guides steel chimney. If you look at in the figure, you will see that the number of guides rope are used to transfer these lateral forces. And in case of high steel chimneys, the mild steel wire ropes or guides are attached to transmit these lateral forces towards the foundation and from the foundation towards the base. So such steel chimneys are known as guide steel chimneys. In guide steel chimneys, all the externally applied loads like the wind forces, seismic forces, etc., and any other kind of lateral deformations are not totally carried by the chimney shells. These attached guys or stays do share these applied loads, and so only this type of chimney is called as a guide steel chimney. Now, talking about moving ahead with the design aspects. So in the third module of our lecture, we'll discuss about the design aspects for the steel chimneys. The sizing of the chimney deals with the four basic criteria. The first one is of the volume of flue gas. The second is the temperature of the flue gas at entry point. The third is the exit velocity which is required for the flue gas and the composition of the flue gas. These four basic points are important for deciding the size of a particular steel chimney. So we'll be focusing on the classification based on the stacks like the self-supporting chimney or the guide stable chimney. So, but depending on these particular four criterias, the first one talks about the volume of the flue gas which that particular chimney has to incorporate. The second talks about the temperature of the flue gas at the entry point, because this temperature also determines the sizing or the thickness of the chimney. The third one is the exit velocity required, because it is essential at the upper end, which is the free end, also to have a particular required capacity to have a chimney. The fourth one is also the composition of flue gas, because the composition which the flue gas will exit from that particular chimney will decide the materials of our chimney as well. So it's very essential to have these particular 4 points for the sizing of chimney. Now talking about the structural design parameters, the first one, as we know that it's shell, which is an important parameter for design parameter for the structural design parameter for a steel chimney. The subclasses for this structural parameter is, the first one is the height of chimney. It is very essential for the wind forces to be acting to decide the height of chimney. The second one is the internal diameter of flue at the exit. The third one is the number of flues. Like if we are going for multi-level flue type of chimney, then it is very essential to have this number of flues as one of the important parameters for designing the shell of that particular chimney. And fourth one, which is also which we already discussed in the previous slide, like this, the temperature of the flue gas at the entry point. Similarly, the temperature of the flue gas is also an important parameter to be discussed for the design of the shell structures for the chimney. Now, continuing the same stuff, if we look at our location of site, because it's very essential to analyze it for the wind and the seismic loads. It varies from the zone to zone. If it is in zone 4, the design will be different. If it is in zone 2, the design will be different. So it is an essential parameter for discussing the design parameters of steel chimney. That the location of site should be analyzed, or the site location or the topographic analysis should be done before designing the particular shell of the structure. So the second is the bearing capacity or the pile capacity of the soil. It is but obvious that the foundation will lay on the soil. So the soil bearing capacity or the pile capacity on which the foundation will rest is also an important structural parameter for the design aspects of the chimney. And the third one is the type of lining. Type of lining can also be associated with the material which is utilized for the lining. So if you look at the lining process, it is also an structural design parameter to be considered while designing the steel chimney. Now, talking about the loads which acts on the chimney shell, the four basic loads which we need to consider as per the relevant IS codes is, the first one is the dead load. The second one is the live loads coming onto the chimney, like the vibration loads in terms of seismic loads, and the fourth is the wind loads. Because as we know that chimney is one of the tall structures which are utilized for the industrial utilization, wind loads will be an important parameter to be considered while designing the chimney shell. And so wind loads will vary as per the location, as we discussed earlier, and the intensity and the pressure of the wind pressure will also be a matter of concern while designing the chimney shell. So these are the four loads, like dead loads, live loads, wind loads, and the seismic load. So these are the relevant standards which we need to follow. If we are going for the RCC chimneys, it is IS 4998. It is IS 4998 Part 1, Part 1. Like it is reaffirmed. Like you can also, if anyone is interested in American codes, you can go for the ACI 30795 code. Also, there is a ASCII code which deals about the steel liners. There is a CISENT code which is a new code which you guys can go ahead for that. Moreover, if you are going for the steel stacks, there's a particular basic code which has to be gone through each and every designer for the steel chimney, and that is IS 6533 Part 1, Part 2. You can refer that as well, which we will discuss in our design problems as well. And before going on the design aspect,